Good
That's
cat.
Baba. Yeah, you can hear Baba whining. Hello, everyone. Welcome back. Good morning. I'm Steve,
And I'm Scott.
and together we're Backyard Musings. I'm in Apple Valley.
And I'm still in Utah for a day or so more. But yep, loving it. And we're talking science and technology today.
Yeah, imagine that.
Yeah.
So what you see on your screen is Antarctica, bird's eye view. It's at the south. You can see the very center is the South Pole, and they found some canyons that were hidden. They discovered them. So I mean, you think Antarctica, you look at it flat. No, there's mountains on Antarctica, definitely.
Yeah.
Antarctica's deep canyons shape oceans and climate. High resolution maps show striking regional differences. Submarine canyons rank among the most striking and complex geological structures on the ocean floor, yet many remain poorly understood, particularly those in remote polar regions like the Arctic and Antarctic. A recent publication in Marine Geology on June 24th presents the most comprehensive inventory of Antarctic submarine canyons to date, documenting 332 canyon systems, some plunging to depths exceeding 4,000 meters. Wow. Would
That's
you like
steep.
to know more?
4,000 meters. That's what? Geez.
That's got to be, that's a more
12,000
than a
feet.
mile.
Over 12,000 feet, right?
Mm, no.
Meter. A meter is 3 feet.
Yeah.
Over 3 feet.
Well, oh yeah, okay, yeah. But
That's
that
deep.
can't be on land. That's got to be off the coast.
Yeah.
Right off the coast.
But that's still pretty deep.
Yeah,
So.
yeah.
All right, this new catalog, which identifies 5 times more canyons than earlier surveys, was compiled by David Amblas of the Consolidated Research Group on Marine Geosciences at the University of Barcelona's Faculty of Earth Sciences, and Ricardo Osorio from the Marine Geosciences Research Group at University of College Cork. Okay, their findings suggest that Antarctica submarine canyons could play a larger role than previously recognized in influencing ocean currents, the thinning of ice shelves, and broader climate dynamics, especially in sensitive regions like the Amundsen Sea and areas east of Antarctica.
Submarine canyons, which are deep valleys cut into the ocean floor, are key features that influence ocean processes. They move sediments and nutrients from coastal areas into the deep sea, link shallow and deep water zones, and support ecosystems with high biodiversity. Although around 10,000 submarine canyons have been identified globally, only 27% of the seafloor has been mapped in high resolution, suggesting that many more remain undiscovered. Despite their importance for marine ecology, ocean circulation, and geology, these canyons, particularly those in polar regions, are still not well studied.
Quote, like those in the Antarctica submarine canyons resemble canyons in the other parts of the world, explains David Amblas. Go on with the quote, but they tend to be larger and deeper because of the prolonged action of polar ice and the immense volumes of sediment transported by glaciers to the continental shelf. Moreover, the Antarctica canyons Antarctic canyons are mainly formed by turbidity currents, which carry suspended sediments downslope at high speed, eroding the valleys they flow through. In Antarctica, the steep slopes of the submarine terrain combined with the abundance of glacial sediments amplify the effects of these currents and contribute to the formation of large canyons.
Amblas and Orosio's latest research draws on version 2 of the international. Let me put that up. We got that slide here. There we go. International bathymetric chart of the Southern Ocean, IBSCO version 2, which offers the most comprehensive and detailed mapping of the seafloor in that area. The study incorporates newly available high-res bathymetric data and employs a semi-automated technique developed by the authors to detect and analyze submarine canyons in their analysis. They examined 15 morphometric parameters, uncovering notable distinctions between the canyon systems in East and West Antarctica.
Another quote: "Some of the marine canyons we analyzed reach depths of over 4,000 meters," explained David Amblas. "The most spectacular of these are in East Antarctica, which is characterized by complex, branching canyon systems. The systems often begin with multiple canyon heads near the edge of the continental shelf and converge into a single main channel that descends into the deep ocean, crossing the sharp, steep sediments of the continental slope."
Ricardo Orozio noted that, quote, "It was particularly interesting to see the differences between canyons in the two major Antarctic regions, as this hadn't been described before. East Antarctic canyons are more complex and branched, often forming extensive canyon channel systems with typical U-shaped cross sections. This suggests like a fjord. This suggests underwater fjord. This suggests prolonged development under sustained glacial activity and a greater influence of both erosional and depositional sedimentary processes. In contrast, West Antarctic canyons are shorter and steeper, characterized by V-shaped cross sections."
According to David Amblas, this morphological difference supports the idea that the East Antarctica ice sheet originated earlier and has experienced a more prolonged development. Quote: "This had been suggested by sedimentary record studies," Amblas said, "but it hadn't yet been described in large-scale seafloor geomorphology."
In addition to their dramatic appearance, Antarctic submarine canyons play a crucial role in moving water between the deep ocean and the continental shelf. They help transport cold, dense water formed near ice shelves into the deep ocean, where it becomes Antarctic bottom water, like soggy bottom, a key component in regulating ocean circulation and influencing global climate patterns.
These canyons also direct warmer water, such as circumpolar deep water, from the open ocean towards the Antarctic coastline. This movement is a major factor in the melting and thinning of floating ice shelves, which are essential for stabilizing inland glaciers. As Amblas and Orozio noted, when these ice shelves weaken or break apart, the flow of glacial ice into the ocean accelerates, contributing directly to rising sea levels. Aha, wait. So we've been talking about lowering sea levels. Now they're talking about accelerating. And so are we going through global warming? Or
no, I think they're just showing that when the ice shelves weaken or break apart, then it accelerates. So recently we just had a freezing in Antarctica. Amblas and Orozio's study also highlights the fact that current ocean circulation models, like those used by the Intergovernmental Panel on Climate Change, do not accurately reproduce the physical processes that occur at local scales between water masses and complex topographies like canyons. These processes, which include current channeling, vertical mixing, and deep water ventilation, are essential for the formation and transformation of cold, dense water masses like Antarctic bottom water. Omitting these local mechanisms limits the ability that models have to predict changes in ocean and climate dynamics. There you have it, folks. I would like to. How do currents form? I mean, they're pretty regular currents too. I'd like to know how that forms in the deep oceans.
I'd like to know if they've been able to find any like weird creatures living down in this bottom.
Well, we did that report on those predators.
Yeah.
We got a lot of views.
Right, but I'm just other things though, like
it's Leviathans.
Just fascinating. So
like Poseidon, the mermaid and merman.
Yeah, the Kraken.
The Kraken.
Yeah,
he's the Kraken. All right, folks. We thank you for joining us.
See you on the next one. Thank you.